So now we know the resistance, and we measure the current with our handy amp meter. And so we say we have 10 amps of current. So what would be the voltage? V equals IR. So V equals 10 times 1. So V equals 10 volts. Very simple. All right? It all depends on what you know. So let's just talk a little bit about terminology. Who can tell me the difference between DC and AC? Nicholas.
DC is direct current when the current's only running in one direction, and AC is alternating current when the current can run in either direction.
Right. DC, the current goes in one direction. AC, it goes in either direction. And what would this circuit be, Thaddeus? DC or AC? Is it going in one direction? What's that? DC, right. It's going in one direction. So the current is flowing in a loop, and that's all it's doing. And let's talk about that, for example. Let's look at a DC circuit, and one place we all have DC circuits or some familiarity with them is a car. Your car has a car battery in it. Here's your car battery. And it's 12-volt battery, like we said. And let's say here's your car headlights. And it's hooked up by wires to the battery, and they're going to be actually hooked up in parallel, like this. Okay? And we'll talk about parallel and series. We'll get to that. And your headlights are on. We haven't drawn any of the relays or switches or anything that turns them on, but they're on. And you have a general feel for how big your car is, so the wire, you get an idea for how long these wires are. They're a couple feet long. How long, just take some guesses, and I don't expect any of you to know this. How long do you think it takes an electron to get from the negative terminal to go through the light and then back to the positive terminal? Anybody want to take a guess?
0.2 seconds.
Can we have 0.2 seconds? Any other guesses? Fast? Fast. Any other guesses?
1 second.
1 second? Okay, everybody's wrong. It's going to take a couple hours.
What?
Yeah. So then the question is, how come your lights don't take a couple hours to turn on when you turn the switch on? I'm saying it takes a couple hours for the electrons to go through. How come it doesn't take a couple hours for the lights to come on? Any guesses?
You mean all the electrons to go through?
For the electron at the negative terminal to get to the positive terminal, it takes a couple hours. But how come it doesn't take a couple hours for the lights to come on? Nicholas?
Because all the electrons, there are electrons all throughout that wire, and so when the battery turns on to turn the headlights on, when it moves one electron, it would turn the lights on, right?
Right, it moves. All the electrons are moving in a really long line, and they're all moving together at the same time. And so that's why the lights come on instantly, even though it literally takes a couple hours for that electron to go through that loop. Now, anyway, that's just kind of a fact. It's not going to really help you with any of your homework. But it's good to know these things. Now, let's look at different types of circuits. Let's say we have a battery here, and this time it's going through 2 resistors. By the way, what do resistors do when electrical current goes through them? Anybody know?
Yeah.
They heat up. Right, so what would be a use for a resistor? A heater. Right, you can use resistors to make a heater. Now, let's say you have a 10 ohm resistor here and a 10 ohm resistor over here. and you have a 10-volt battery, and you want to know the current I in this segment of the wire. What do we have to do to figure that out, Andre?
Does the current split when it gets to the first dot there?
Yes, when it gets to this dot, which is also called a node, some of the current will go that way, and some of the current will go that way. Now, here's the thing to keep in mind. The voltage across each resistor, hold on a second, class. The voltage across each resistor is still 10 volts, because when you're at this branch of the wire, this node here is 10 volts. So every wire coming off of that is 10 volts until it gets to whatever element is there, in this case resistors. The voltage at the bottom of the battery, the negative terminal here, we call this ground. And when you're analyzing circuits, ground is always 0 volts. This is the symbol for ground. This is the electrical symbol for ground. It looks like this. So that's the ground side of the battery. The other side is 10 volts. So what would be the current through each resistor? What's the current through each individual 10 ohm resistor? Anybody know? Yeah, right. 10 divided by 10 is 1. So V equals IR. So 10 equals I times 10. So I equals 1 amp. 1A through each resistor. So what would be the total resistance up here through this leg?
1.
No, 2. Look, because there's 1 amp has to be going through here, and 1 amp has to be going through here. Right, it has to split. So we've got 2 amps right here. So you have to figure this out, and the way you do it is by solving what's called a resistor network, and it's pretty simple. You have to know the rules for whether resistors are in parallel or in series. In this case, they're in parallel. Let's go over this in a little more detail. So here's the way you do it is you come up with an equivalent resistance. So let's just do the example we just looked at. So here's our circuit. We need to simplify this so we can solve it just as one resistor. So let's say this is 10 ohms and this is 10 ohms. You simply go like this. You would redraw the circuit as a circuit with one resistor, and this is a 5 ohm resistor. That's the equivalent circuit. This is the equivalent. Now, let's do a different circuit. This is simpler. Let's look at this one. So there's 3 resistors. We have a 10 ohm, a 1 ohm, and a 5 ohm. This is what's called series. They're all in series. What do you think the equivalent resistance of that is going to be? No. They're 16, right. No. You're adding up 3 resistances, so you get this is equivalent. The equivalent resistor is a 16 ohm resistor. So you can get rid of all of these and hook your circuit up. And there you have it. Okay, so let's make one more example. So now just looking at the resistances and labeling them. Hold on a second. Sorry. These resistors are in parallel. These resistors are in series. And so you need to know those terms, parallel and series. And you can have combinations. What if I went like that? Now I got parallel and series. What I would do is I would figure out this equivalent resistance first, then do the rest of the network. And we'll talk about the rules for how you do this.